we talk about equation of line of symmetry, you must always remember to put a x equals to. Okay, we can tell based on the minimum point that this has a value of 1 for the first graph. X value is 1. That is insufficient for us to say that that is the line of symmetry. We need the entire equation, x equals to 1. For the second graph, we have our line of symmetry, x equals to 1 as well. For the third graph, this time our x value is -3. So our equation will be x equals to -3. So these that I circled, they are the lines of symmetry. Okay, moving on. Now we have to sketch the quadratic graphs based on just solely the equation. Okay, the first one I believe was already done in the video for you. So I will not go through the first one, but I want to draw attention to this portion. Y equals to x minus a, x minus b versus y equals to ax squared plus bx plus c. The one that I just wrote down was what was mentioned earlier on. Okay, then we talk about the coefficient of x squared, which is the a. Depending on the sign, will show us whether it's a sad face or happy face. Then now they are telling us that quadratic equation can also have this particular form. This second format. Compare them. A different format, right? One is a factorized form. Factorized meaning there are brackets. You can expand them. The other is already the expanded form. So please don't get confused. Both of them, they represent quadratic expressions, quadratic equations. Because when you expand this, okay, watch closely, x times x. What do you get mentally? Don't need to write down. Mentally, what do you have? X squared. You have x squared, right? So x squared already tells us it is quadratic. That means it's going to be a smiley face or a sad face already. Next, we'll take x times -b, then -a times x, -a times -b. So we will end up with a separate quadratic equation. The reason I'm not expanding it out for you is because in this case, we expand, you're gonna have okay. This part don't copy, otherwise it will confuse you. Just watch the screen only. When I expand it, you will get x squared minus ax minus b minus bx plus ab. And then when you continue, you get x squared minus x a plus b plus ab. Now, think about it carefully. The red color expanded form, does it have the form of ax squared minus bx plus bx plus c? So here's the confusing part. So many a, well, the a's are different. That's why it is confusing. The a's are different, but look at the coefficient of x squared. This part don't copy down, otherwise it may confuse you, okay? So look at the coefficient of x squared. We have a over there. In the second line, we have 1. So far, it is the same format. It's just that in the red color form, the coefficient of x squared is 1. Next, we have plus b as the coefficient of x. Look at the expanded form. Coefficient of x is actually -a plus b. It is the same format. It's just that the a appears more than one star, so it is a bit confusing. Then we have a constant plus c versus plus ab. Now this confusion could have been cleared up if we didn't choose to use a. If we didn't choose to use a and b. If I had chosen to use, for example, 3 and 4, for example, and then I will end up with actual proper numbers as coefficients and constants. Then you can see that they are actually related. Okay, so in summary, what I want you to know over here is both of them, they are quadratic equations. you are expected to know how to sketch both of them. Y equals to ax squared plus bx plus c. Okay, must know how to sketch this. And you must know how to sketch this also. Both are quadratic equations, just the format is different. Now, which is easier to sketch? This is way easier to sketch. Let me demonstrate why. Okay, so let's talk about the second case. Y equals to negative x plus 4 multiplied by 2x minus 5. Okay, ready? So you see, roots of equation. Roots of equation, what equation? I want you to include one line over here. What is the equation? The equation is y equals to 0. Include that line, y equals to 0. If you don't have that line, doesn't make sense. Okay? Why doesn't make sense? Look, this is the equation. Y equals to blah, 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 blah. If I ask you for the solution to the first equation, your answer should be, there's no solution. There is no solution. There are two unknowns over there, x and y. There are infinite solutions. Only when I say, when y is equals to 0, then you write. Before this, x equals to 2, x equals to negative 3, right? Before this, you should write, since y equals to 0, x minus 2, x plus 3 equals to 0. From here, once this is equal to 0, we can say x minus 2 equals to 0. Has to be, right? The other case will be, or x plus 3 equals to 0. It has to be either one of these two. Therefore, we say the roots will be x equals to 2 or negative 3. From there, look at the x-intercept. Negative 3 and 2, as expected. Because our horizontal axis, our x-axis, has the equation of y equals to 0. Okay? So in our quadratic equation, when we talk about the roots, we are actually referring to the case where y is equal to 0. So let's continue for the second example again. Roots of the equation y equals to 0. Can you fill up by yourself? What are the two cases when y is equal to 0? I'll just write down the starting. So since y is equal to 0, we have negative x plus 4, 2x minus 5 equals to 0. What are the two cases over here? Okay, try. Have you done it? Actually, all of this should have already completed those, right? But at least use this time to think. Understand what you were doing during your HPL. What are the two cases? Something times something equal to 0. Either one or both of them would be equal to 0. You need to get that logic correct. Otherwise, it's painful for you to memorize things. Something times something equal to 0. Okay, so first case, I'm going to call people after I say the first example, so you better listen carefully. The first case we have, I'm going to ignore the negative sign because I'm going to divide both sides by 0, by negative 1. Divide both sides by negative 1, negative sign disappear already. Don't need to be bothered about it. First case, x plus 4 equals to 0. That's the first case. So what is the second case? Second case. Chloe, what's the second case? Is the first case is x plus 4 equal to 0? Yes, the second case, 2x minus 5 equals to 0. Okay, we didn't need brackets over here, but I'm just putting them down so that you can see it clearly. So based on the first case, x plus 4 equals 0, we end up with x equals to negative 4. The second case, x will be equal to 5 over 2. Okay? With this, I don't want to move on to the next column yet. Let's do the roots for the next equation. Make sure we know how to find the roots really quickly. So again, y equals to 0. Jermaine, what is the first case when y is equal to 0? 2x plus 3 equals to 0. Okay, second case, Arisha. x minus 1 equals to 0. So for the first case, we end up with x equals to -3/2. Second case, x equals to 1. So I know my graph is going to cut the x-axis at 1 and -3/2. Okay, so these were the examples. Eventually, the instant answer is, when you talk about the roots, mentally, you just look at this part. Okay, look at that. X minus 2, you change the -2 to become +2. Just change the sign only. That's the instant answer. When you see x plus 3, the root is actually -3. Just change the sign only. But when we have, okay, let's talk about this one first. X plus 4, change the sign. X equals to -4. But when we have a case of something times x, then it is not just changing the sign. Yes, the sign will change, but there's another step. So you shift the 5 over, meaning you add 5 to both sides, then you divide by 2. So you end up with 5/2. Okay, so these are the roots. Next, we need the line of symmetry. Equation of line of symmetry, to be precise. Okay, lines are described by equations. Equations have equal sign. A left side equal right side. So in our parabola, whether it's a smiley face or set face, in your syllabus in Sec 2 only, Sec 2, vertical lines. Vertical lines are like our HDB blocks. They are x equals to something, x equals to something. So you can safely write x equals 2 already. For all your cases, x equals 2. That is the start of your line of symmetry. Next point. How do we decide what a line of symmetry is? Look at all the previous examples for our parabolas that we have drawn. Okay, so let's start with this portion. If I tell you that the roots over here, this root, let's say it is 1. Let's say this is, for example, 5. If I've got 1 and 5 as the intersections, the intercepts, what do you think is the x-axis, the x value over here in the middle? Based on the idea of symmetry, can you see that it is in the middle? It is supposed to be in the middle of 1 and 5. So what is in the middle of 1 and 5? Is it 5 minus 1 equals to 4, then 4 divided by 2 is 2, and therefore the answer is 2? Is it done that way? No. We are looking for the middle of 1 and 5. In other words, we are looking for the average of 1 and 5. So average, how do we find average? Of two numbers. Add and divide, right? So 1 plus 5 is 6. 6 divided by 2 is 3. So this has a value of 3. Let's check. We've got 2 units here, and we've got 2 units over here. So this line of symmetry, in this particular case, will be x equals to 3. The way we find the middle, the line of symmetry, whether it is positive numbers, negative numbers, I don't care. Let's say this is 1 for ease of calculation. Let's say this is a value of, clearly it is negative. Let's say negative 7. Negative 7. So what is in the middle of negative 7 and 1? Don't be scared. Same approach applies. We are trying to find the middle of negative 7 and 1. We are trying to find the average of negative 7 and 1. The average of two numbers, don't care positive, negative, just add and divide by 2. So negative 7 plus 1 over 2, we get negative 6 divided by 2, negative 3. So this tells me that this center is negative 3. Okay, negative 3. Let's double check. How many units are there over here? 4 units. Over here, 4 units. So my line of symmetry is x equals to negative 3. This is how you find the line of symmetry using the roots. And that's what we just found out earlier on for all cases. Thank you. The first example, we have the roots as -3 and 2. If the roots are -3 and 2, I am trying to find the middle value for x, the average value of x. So we write x for line of symmetry, x equals to 2 plus -3. I am finding average. As simple as that. And then we get x equals to half. Your answer, during your exam paper, right, they'll say, answer, you're expected to write down something. So happily you write -half. And this is a 1-mark question. You get 0. Because you need to write x equals to. Then it is an equation. Okay, so next case. Look, you have already written down x equals 2. So we have our two values of the x-intercepts, -4 and 5/2. Are you able to find the average? Got a calculator? Don't be afraid, use a calculator. Just right now, -4 plus whatever you see, -4 plus 5/2. And divided by 2. Use your calculator to do the difficult work for you. Huh? You have -3/4. So the equation is x equals to -3/4. Okay, try the next one by yourself. What is your value of, what is your line of symmetry? What is your equation of line of symmetry for the third case? Find the average of your roots. So I'm spending more time for this because confirm will come out for a test. Confirm tested for exam. Okay, so look at the header. It says that there are a few things that you need to take note of. Intercept. Okay, so write down your notes, either in your iPad or your physical notes. Intercepts, this refers to x and y intercept. Okay, so x intercept, this refers to the roots that you have already found. These are the roots that you have already found. Then how about the y-intercept? How to find the y-intercept? Roots that you found. The y-intercept, just like your straight lines, y equals mx plus c. To find the y-intercept, you let x be equal to 0. Because your y-axis has an equation of x equals to 0. So in this case, let x be equal to 0. You let x be equal to 0, and your calculation will tell you what the y value should be. We covered this in the previous lesson also. Okay, so that is the point about intercepts. Line of symmetry, we have already learned how to do it just a while ago. Next one will be your minimum, maximum point, your turning points. So how do we find the turning points now? Turning points refers to either minimum or maximum. So let's go back to the graph. Okay, so it looks like this. Looks like this. So look like this. -3, -1. Okay, so this x value -3. Okay. Pay close attention to what the line of symmetry cuts through. The line of symmetry cuts through the turning point. The line of symmetry cuts through the turning point. The line of symmetry cuts through the turning point. In all three cases, we have our equation for the line of symmetry. Look closely at what the line of symmetry equation looks like. It says x equals 2, x equals 2, x equals 2. They are telling us the x coordinate for the turning point. So over here, x equals to 1, see it has a value 1. X equals to 1 again, it has a value of 1. X equals to -3. See, the turning point has a x coordinate of -3. So we have half of the coordinates of the turning point already. The moment you wrote down the line of symmetry, you already have the x coordinate of the turning point. And then how to find the y coordinate? Substitute back into the equation. You were given an equation, y equals to ax squared plus bx plus c. Or, in this case, the format is y equals to x minus a, x minus b. When you have the line of symmetry, you are saying I have the x value. You put the x value into these x terms. And we substitute, we get the answer. So let's take a look for the intercepts. When y is equal to 0, these are the roots that you found. These are the roots that you found. The next intercept you require is a y-intercept. So you say when y is equal to 0, so when x equals 0, y equals to -6. So here we have our x-intercepts in the first line and the y-intercept in the second line. Next, we have our line of symmetry, which you already found, x equals to -half. And finally, our minimum, how do I know it's a minimum point? I get to that in a short while. The turning point happens when x equals to -half. Watch. It is the same. When you have your line of symmetry, you already have your x coordinate for your turning point. X is -half. And what about the y value? How do I get -6.25? I had to substitute back into the equation where here x minus 2, x has a value of -half, minus 2, multiplied by x plus 3. X has a value of -half plus 3. Calculator will tell you that it is -6.25. So now you end up with very important information. First, you have your intercept. X equals to -2, x equals to 2, x equals to -3. You have your y-intercept, y equals to -6. You have your line of symmetry, x equals to -half. And you have your minimum point, rather your turning point, -half and -6.25. You are supposed to piece them all together. Okay, so I also mentioned that how do you know it is a minimum point? You can do a partial expansion. Remember, when we want to decide whether it's a parabola opening up, small face, or parabola opening down, set face, we have to look at the coefficient of x squared. In this case, this format is not. It is not y equals to ax squared plus bx plus c, where you can simply look at the sign of a. We can simply look at whether a is positive or negative and decide smiley face or sad face. But it's not. So what you can do is to do a partial expansion. I'm only interested in the x squared term. So in this factorized format, I am going to expand partially only x times x. So that gives me x squared. Of course, I can continue with the expansion, but no matter how you multiply, you are not going to get another x squared. Can you see that? There are 4 multiplications, 4 arrows, 4 multiplication. Only the first arrow gives you x squared. The rest don't give you x squared. So we just do the first part, x squared. And then we have it. What is the coefficient of x squared? It is positive 1. Positive 1. Positive is a good thing. You get a smiley face. You get a parabola opening upwards, as shown. This parabola opening upwards is going to cut your x-axis at 2 points. The 2 points are x equals to 2 and x equals to -3, as shown. -3, 2. Your smiley face is going to cut the y-axis at -6. It cuts at -6. Your smiley face has a minimum point of -half, -6.25. -half is the x-coordinate, negative on the left-hand side of your y-axis. So -half and -6.25. -6.25 lies below -6. So your minimum point must be below your y-intercept. Okay, in this case, they are very close together, so they look like they are the same level. But they're different. Minimum must be lower than any other point. And this is our final sketch. Okay, so we're going to continue from here. Second case, we have already done our x-intercepts. So you can label this. These are our x-intercepts. So now we are only left with our y-intercept. So y-intercept happens when x equals to 0. Okay, objective now, intercept. We've already done x-intercept. So now we want to find y-intercept when x equals to 0. This is me finding the y-intercept. It happens when x equals to 0. Comma. Put down all the x values. Y equals to, look, y equals to, I'm just copying, negative. Okay, see, it's a negative. Open bracket. After the open bracket, it says x. Instead of x, I'm going to put 0. Then plus 4. Plus 4. Close bracket. Open bracket again. 2x minus 5. 2 times 0. I'm too lazy to write 2 times 0, so I'm just going to write 0 minus 5. Eventually, you're going to get so lazy and yet so fast that when you look at this, you can do it in your mind already. -4 times -5. Can you see that? Mentally change all the x to become 0. -4 times -5. That gives us 20 lah. Okay, but for a start, we do all the working. -4 times -5. Okay, we get 20. Okay, so now we have our y-intercept. This is our y-intercept. What did they say next? We need our line of symmetry. Line of symmetry is x equals to -3/4. We need to write x equals to. You cannot just write -3/4. The final portion is our turning point. You can write turning point here, but rather we be more specific. Is it a maximum or minimum point? So to do that, we need to look at the coefficient of x squared. I'm too lazy to expand everything out. So I only want to expand and get the x squared term. So look, there are 4 arrows that we can draw for our multiplication. Which of these arrows will give you an x squared term? Go through that thinking process. Which one will give you an x squared term? It is something that you can do. And it is only the first product, the x times the x. So what we end up with will be equals to -x times 2x gives us 2x squared. Then blah, 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 blah. Not interested at all. And then we have a negative sign over here, which we still need to expand. And we end up with -2x squared plus blah, 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 blah. I don't care what they are. Can you see that? Expansion to get the x squared term only. So this is a negative coefficient. See, -2, negative, set. We are expecting a parabola opening upwards. You can draw that already. In a space, parabola opening upwards. And then you ask yourself, is it symmetrical? If it is not symmetrical, erase, draw it again. until you're happy with it. Draw until you're happy that it is symmetrical. Okay? Once done, we're going to fill in the blanks for our parabola. Oh, sorry. What was that? Oh, we are saying maximum point, but I haven't found the coordinates yet. Maximum point equals to x value is -3/4. -3/4. Okay, it is the same x coordinate as your line of symmetry. Now we need our y coordinate. When x is equal to 3/4, I'll just put it over here. When x equals to -3/4, our y value will be negative x plus 4, -3/4 plus 4. Plus 4 bracket 2x, 2 times of -3/4, then -5. Okay, so this is me trying to find the y coordinate. How did I do that? I substitute the x value. Which x value? Line of symmetry into the equation. Similar to how you find your y intercept. You sub the x value when x goes 0. But this time is when x goes to -3/4. So calculate all these out. 4 minus 4 times -1 multiplied by bracket 2 bracket -0.75 bracket -5. We get what? Did you get 21.125? No way. Cannot be. Okay, I made a mistake somewhere. Really? 21 point something. Say it, 21. 1/8. What are my intercepts? What is my y intercept? My y intercept is, oh, my y intercept is 20. Okay. The reason I got concerned was because this is a very big number. Because I forgot my y intercept, right, is actually 20 lah. So 20, 21, and 1/8 rather close. Okay, rather close. So now our maximum point is 21 and 1/8. Okay, we have all this information already. Fill in the blanks in your graph. Maximum point. Put a cross. Because that's the maximum point. I know this point has a value of its coordinates of -3/4 and 21 and 1/8. Okay. Then what else do we know? We know the dotted line, our line of symmetry. Put that in also. Put it at the top, put it at the bottom, doesn't matter. X has a value of -3/4. Okay, so far? What's missing? X and Y axis. Think about it logically. You can start with either X or the Y axis, up to you. Let's start with the Y axis, okay? Is the Y axis going to be on the left side or the right side? The Y axis. Is it going to be left? Oops. Is it going to be on the left side, Y axis, or right side? The clue is the line of symmetry. Line of symmetry says x value. X value is -3/4. So think about it. Which of these graphs, the green or the red, can, or rather will, result in your line of symmetry at the correct position of -3/4. Let's start with the green graph. Okay. If the green graph is correct, if this is my y-axis, then everything on the right-hand side of the y-axis should be positive. Like this. Everything here positive. However, this contradicts. This says our x value is -3/4. So it doesn't make sense really. There's a contradiction. It cannot be the case. So we need to change. This is impossible. So logic tells us that our y-axis must therefore be here. If our y-axis is on the right-hand side of the line of symmetry, then everything on the left-hand side, everything here, when I draw my x-axis, it should result in the maximum point having a negative x coordinate. So now that I've drawn my y-axis, can you see there's an intersection between the graph and the y-axis? What do you think that value is? What do you think this value is? The y-intercept. Did we already find out? Everything must fall in place one. Cannot have contradiction. What is the y-intercept? It's 20. So this has a value of 20. Compare the other y value that you have, 21 and 1/8. Is 21 and 1/8 more than 20? Yes. So it should lie above, which is the case. This has a value of 21 and 1/8. Okay. So the y-axis is done. The y-intercept is done. Line of symmetry, turning points, all done. But we're missing one more thing. The x-axis. So x-axis, you should have an idea of where it is already. Since we already have the y value of 21 and 1/8, we have the y value of 20. Where should the y-axis, the x-axis be? It's be way below. If this is 21 and if this is 21 and 1/8, if this is 20, going by the correct scale, my x-axis should be all the way down, quite low. In fact, it should be lower than this, but we are doing a sketch, so it's not too bad. Okay, we are doing a sketch. Let's see what happens for our graph. It's a parabola opening downwards all the way. So if this is my x-axis, where are my x-intercepts? It says the x-intercept will be -4 and 5/2. Which intercept, this or this, has a value of -4? And which one has a value of 5/2? You have to decide. Left-hand side is -4. Right-hand side must be 5/2. Okay? And put in the 0. Write down your equation of graph. Y equals to -x plus 4, 2x minus 5. Okay, now, I'm just going to now show you what happens if I didn't draw my x-axis low enough. You don't have to do this. I'm just going to show you. We know the x-axis is going to be below. What happens if I draw it here? Okay, then our value 0 is here. This has a value of -4. Whereas this has a value of 5/2, which is 2.5. Can you see the problem? You see a problem? The problem is that this width, this part is supposed to be 2.5 units wide. On the left-hand side, if we go by the same scale, this will be negative 2.5. Using the same size, this will be negative 5 already. How come my negative 4 ended up on the left-hand side of negative 5? See, this is a scale problem. Where else is a scale problem? Well, apparently this is 20 units, but this same size is 1 and 1/8 units. Doesn't make sense. So you end up with a drawing that is not well scaled. So to prevent that from happening, we need to be very mindful about where we draw our horizontal and vertical axis. So remove all this. We know that it should be very low x, so that this will be 20 units, whereas this little bit will be 1 and 1/8. Then our x-intercepts will make more sense. Negative 4 and 2.5. Not the best, but at least it is better than the previous case. Okay, so now we're just going to do the next portion, the last one. Consolidate what we have. The first portion, our roots. In this case, our x-intercepts is done already. So based on this, x-intercepts done. X equals to 1 and x equals to negative 3/2. Our line of symmetry done. The next intercept we need is our y-intercept when x equals to 0. Every time we say when x equals to 0, we are trying to find the y-intercept. Because y-axis is block. So vertical line is a block. Block 0. X equals to 0. Substitute. I think we can do it mentally already. When x equals to 0, we end up with 3 times negative 1. Negative 3. No need working. Y equals to negative 3 times negative 1, negative 3. So this is our y-intercept. We got y-intercept, we got x-intercept, we have our line of symmetry. We now, let's put it down here, line of symmetry is. I don't like to write line of symmetry equals to, because you end up with y equals 2 again. X equals 2 again. Then this just looks weird to me. So I rather write line of symmetry is x equals to negative 1/4, negative 1/4. So the next portion, we need to find the turning point. Is it going to be a smiling face or a sad face? Look at the equation. We have to do expansion, but we only need to do partial expansion. This is the only multiplication that results in x squared. 2x times x, giving us positive 2x squared. Positive 2x squared. Coefficient is positive 2. Happy, positive, smiley. So here we can draw our parabola opening upwards already. So draw a parabola opening upwards. Make sure your parabola is symmetrical. So just sketch. If you're doing on iPad, then yeah, you got to try until you're happy with it. Doing on paper, then you have to erase and erase. Okay. So we are expecting a minimum point. Smiley face, minimum point. So right now, minimum point equals to x coordinate is already done. X coordinate is here, negative 1/4. Put down negative 1/4. but we need the y coordinate. So in a separate working, when x equals to -1/4, what is our y value? It says 2 times x. So 2 times -1/4 plus 3. That's the first half. And we have x minus 1. So -1/4 minus 1. Okay, I am trying to find the y coordinate of the turning point. So key them carefully in your calculator, exactly as what you see, 2 times of -0.25 plus 3, close, open, -0.25 minus 1. So I get -3 and what? 3 and 1 away again. I see the 1 away. Is it correct? Henry, correct? -3, 1 away. Okay. So this is our y coordinate. -3 and 1 away. Okay, can fill in the blanks. Out of all this information, for my minimum point, coordinates -1/4, -3 and 1/8. I can draw my vertical line. That is my line of symmetry. Okay, just put it somewhere. X equals to -1/4. I like to put the equation for line of symmetry further away from the graph, because I know I need to draw a lot of x-intercept, y-intercept, vertical axis, and horizontal axis. So I put what I can further away. So x equals to -1/4. And now I like to draw my y-axis next. I need to decide, is the y-axis going to be on the left-hand side of the line of symmetry or on the right-hand side of the line of symmetry? To do that, anyway, you only have 2 options. You choose one, you check, wrong, must be the other one already. So instead of having to erase again and again, look at the x coordinate. X has a value of -1/4. So this must be on the left-hand side. Negative being on the left-hand side, right? So I know my line of symmetry lies on the left-hand side of the y-axis. Therefore, my vertical axis will be on the right-hand side. This will be our y-axis. Once you've drawn your y-axis, notice that your y-axis cut the graph. That is called the y-intercept. So this has a value. What is this value? What is the y-intercept? We did our calculation. Says y is -3. So put on -3 over here. Look at your graph again. Does it make sense? Is your minimum point lower than the y-intercept? Has to be, right? Minimum literally means the lowest. And what is the level of your minimum point? The level of your minimum point is level -3 and 1/8. This is below -3, but it's quite close to -3, as is the case over here. Look, your minimum point is just slightly lower than level -3. So everything makes sense so far. We're only left with our horizontal axis. Horizontal axis, our x-axis, we need to decide where to draw it. If I know that, if I've already drawn this to be -3, and this is -3 and 1/8, I know my x-axis must be above already. This has a gap of 1/8. 1/8 units, so tiny, 1/8 units. Then I need to go pretty high up in order to get my x-axis. Because this is only 1/8 unit, I need to move up by another 3 units. This is another 1/8, 2/8, 3/8, 4/8, You see that I have a long way up to go. But because it is a sketch, we are a bit more forgiving. But as far as possible, we still want to try and do it properly. Okay, parabola always opening up. My x-axis should be quite high. This is going to be my x-axis, and I'm going to look at my intercepts. Oh, why my intercept looks so funny? I think it's shifted. My intercepts were x equals to -3/2, x equals to 1. Okay, so this has a value of 1. This has a value of -3/2. And in the middle, this has a value of -1/4. Then state your equation. Y equals to 2x plus 3x minus 1. So there we have it. We have the line of symmetry, we have the equation of graph, we have all the intercepts, we have the intercepts and the turning points, all in the graph. So everything must be okay, now we have a curve. Y equals to x squared plus x minus 6. Cuts the x-axis AC, y-axis B, blah, blah, blah. Find ABC. So look, we have a case of y equals to ax squared plus bx plus c. Compare y equals to ax squared plus bx plus c. Our a value is +1. Let's just write 1. So we're expecting a smiley face, as shown. Now, to find the intercepts, because that's what A, B, and C are, we need to let something be equal to 0. The easiest one will be for y-intercept. That is always the easiest, y-intercept, because we just let x be equal to 0. Okay, every time. This is a confirm one. Any graph it is, straight line, curve, cubic, so on and so forth. When x equals to 0, you are going to get a y-intercept. So substitute in y equals to 0 square plus 0 minus 6. Of course, you get -6. So our y-intercept must be -6. B has a value of -6. If you want the coordinates of B, it will be 0, -6. That is for B. Where did the 0 come from? Over here, x equals to 0. Why did we let x be equal to 0 in the first place? Because the y-axis, this line, has an equation of x equals to 0. In addition to it being called the y-axis, it has an equation. It is x equals to 0. So B, y-intercept, is the easiest. As good as 3 marks, give away. Now we need the A and the C value. The intercepts, the x-intercepts. We have to let this graph. What is this graph called? Y equals to 0. In addition to it being known as the x-axis, it has an equation, y equals to 0. We have to let y be equal to 0. So to find the x-intercept, let y be equal to 0. When that happens, we end up with 0 equals to x squared plus x minus 6. At this point, you need to solve a quadratic equation, x squared plus x minus 6. You only learned one method to do it so far, and that is by factorization. X squared. We need a 6. We need a -6 over here. Let us put in the 3 and a 2 without the sign yet. So we end up with 3x. We end up with 2x over here. In order to get -6, I need one of them to be negative. And in order to end up with a positive x, I would want this to be -2x. So this must have a value of -2. So I have now factorized this to become x plus 3, x minus 2 equals to 0. Okay, so we end up with x equals to -3 or x equals to 2. That's it. For solving, for finding the intercept. So we have coordinates of A to become, we need to put the left-hand side, the negative for the left-hand side, -3. This has an x value -3, this has an x value of 2. So -3, 0, and C will be 2, 0. Is the graph drawn to scale? Really? Does this look like this 3 units and this is 2 units? Not really, right? The vertical axis should be shifted to the right hand side. Okay, so that's just one small point to make. Okay.